We're going to evaluate the integral of e to the x sine x using an easy method. It's my favorite way. Normally, we integrate this using integration by parts twice, but there's a shorter way. We're going to use Euler's formula. Now, stay with me. This becomes very easy to work with. Here's our sine of x, and the sine of x is the imaginary portion of e to the ix. So if we substitute that in, our integral becomes the imaginary part of the integral of e to the x times e to the ix. And if we merge these two together, we get the imaginary part of e to the 1 plus ix. And this, my friends, becomes like a super easy integral to evaluate. E to the x is super easy to integrate. So that becomes the imaginary part of e to the 1 plus ix over 1 plus I plus our integration constant. Now we need to get the imaginary part. So what we're going to do is substitute back into Euler's formula to get our coses and sines back right here. And to get the imaginary part, we need to put it into this form, a plus bi, where a is the real part, b is the imaginary part. That's the part we want. So to get our fraction into this form, we're going to multiply the top and the bottom by the conjugate. And knowing that I equals the square root of -1, so I squared equals -1, if we expand the brackets, FOIL it out, and factor, do a bunch of algebra, this is the result you'll get. E to the x over 2 times cos x plus sine x, this is the real portion, real part, plus the imaginary part, which is sine xi minus cos xi. So this imaginary part is our answer with this factor in as well. And that's it. Good luck on your midterms, final exams. I know that integrals are not the easiest thing to learn, but the more you do, the better you'll get. Cheers.